Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we have a quick train and bee puzzle, question, whatever you want to call it, to go over today. Now, inspiration for this puzzle, it's been floating around for many years. It's a pretty common puzzle that people have heard, probably in different forms, different ideas that way as well. They all have the same trick though, and I saw a version of this floating around again on social media. And the interesting thing about when I saw it floating around this time was that the story was told as the puzzle was given to a family. The kid was able to solve the puzzle really quickly, presumably using the trick we're going to talk about today. The parent had more trouble solving the puzzle. They were overthinking things there. So spoilers for this video, don't overthink the solution about these trains and a bee that's flying around there as well. We'll get to the question in a moment. Let's just do our setup of the bee and the trains first. So, two trains. The setup here is that they're on the same track 100 miles apart, heading towards one another. First train is traveling at 30 miles per hour, second train traveling at 20 miles per hour. Don't worry, I'll remind us about all the numbers when we get to actually solving the problem, but 100 miles apart, going towards one another, 30 miles, 20 miles per hour for the two speeds of the train. Now, we also have this very fast bee in our problem. So maybe you want to update this to a different animal running back and forth. If you want to bring in superheroes, maybe our bee can be Ant-Man flying back and forth quickly. It's flying at a speed of 60 miles per hour in this question, and it instantaneously can change directions. Now, want to just point out here right away that when you read a question, right, if this was a normal question on a quiz or in a website or something you're reading, it probably would be all together. So I split it up here, split up the different parts. But regardless, something like this should set off some alarm bells. Hey, this is interesting. Why are we being told about this instantaneously changing directions? Stuff like that as well. We want to keep that in mind at least for what's coming later. Now, what is the actual question? Well, we have the two trains, and the idea is the bee is flying back and forth over and over and over between those two trains until the trains meet. Let's not worry about are the trains crashing, blah, blah, blah. Let's pretend they can decelerate instantaneously if the bee can change directions instantaneously, so everything will be happy at the end. And our question is how many total miles the bee flies during this time. So let's start answering the question, and we have our reminder, do not overthink this. So right off the bat, we have our two trains. So our one train is traveling here. Let's say the first one is 30 miles per hour in that direction. Our other train, right, traveling the opposite direction towards one another. This is 20 miles per hour there. And we were also given, of course, the distance between those two trains. So let's just kind of label this quickly here, that we had 100 miles between those trains when we started for the problem that way. And for the bee, right, let me draw the bee in the middle here. Remember, the bee is traveling back and forth. So let me kind of do these two arrows there. And the bee in this setup at least was traveling at 60 miles per hour. So that's what we have in this scenario there. Now, one thing that is a helpful problem-solving strategy is sometimes you might want to just ignore the question for a moment or ignore things and figure out what you can find. Figure out what sub-questions there are. Now, I know I drew this last anyway, but let me delete the B for a moment. When we're staring at this diagram, there's a natural question that comes up, right? I'm going to put the B back up here, but the natural question is, right? So we have this natural question. What is the time until the trains meet, right? We have this natural kind of question that we could figure out in that scenario. So that is also a pretty simple related rates question. So the trains are 100 miles apart, right? We could even practice with some units a little bit here, right? What is their relative speed? Well, their speed is going towards one another, right? So every hour, and this kind of gives away the answer a little bit, they get 50 miles closer to each other, right? They're traveling 30 plus 20, 50 miles per hour. Miles cancel, we end up with hours, and our number is 2. It is 2 hours for the trains to meet in this scenario there. Now, in certain questions, maybe this isn't helpful. There will be times where you do a problem, you ask this sub-question, it turns out that maybe it's not super relevant to the final answer. That's okay. If it starts getting you comfortable with the question, that's still a positive. Oftentimes, regardless, this will help you out that way. However, for this question, it pretty much answers the problem there. Not quite, but what is our key idea? We had this alarm bells going off from before, right? What is the key to this problem? Because that B can instantaneously change direction, right? The B is always, let me just say, at 60 miles per hour. The B is always traveling at its speed. It's going back and forth, yes, but because it can instantaneously turn around, or that's the assumption of our problem, it's always traveling 60 miles per hour. Meaning that, wait a second, we know that the B in total is traveling for, right, 2 hours here. We know that the B is always traveling at 60 miles per hour. So what if we put these two things together? What does that give us? Well, distance, right, is rate times time. So the total distance that we have is 60 miles per hour times 2 hours. In that case, this is going to give us 120 miles there. So we actually can put stuff together quite nicely to come up with our final answer of 120 miles in this case. Right? The key thing was, in the end, the B was just always traveling at a speed, so our sub-question is, how long was the B traveling? Now, some challenge questions from here, right? You can figure out the position. You can do this. It's possible to do this the way that presumably stumped the parent. How long until the B meets the first train? Come back, come back. Is there a pattern? Can we come up with some infinite sequence or series there? Yes, more complicated, but might be interesting to think about that a little bit. Also try to think about how some of the parameters would change the answer. In fact, with our trick, things become quite easy, right? We have here then, okay, depending on the speed of the two trains, the distance they are apart, the speed of the B, can you come up with some general formula for the final answer? Very similar to the calculations we did, but that's just a good way to double check you understand everything if you're comfortable with those variables and things like that as well. Otherwise, that is a great place to end for the day. Share any thoughts for new topics or new approaches you might have had for this puzzle in the comments below. While you're there, give us a like and subscribe so you can always see our latest updates and it helps us out. Otherwise, thank you all for watching and I'll see you all next time. Goodbye.